Hello, Assalamu alaikum. Myself is Jawadu Karim, and now I will try to solve the question. The first question was about the minimum spanning tree in a distributed system. So, to think about a distributed system, let's think about A, B, and C, D as a server, and the edges connected there. Edges connected there. So, the edges connecting them have some weights. The weights can be latency, cost, anything. So, our goal is to find the cheapest way to connect all of them, and I will use the Kruskal theorem in this distributed system. So first, I will try to sort the edges. So from the smallest to the largest, and then I will pick the cheapest edge combo of all of them. And if I will see if they have are in a loop, and if they are not in a loop, then yes, they are in an minimum spanning tree. This right here from A to C, then A to B, and then from B to D, 3 plus 5 plus 2 is the most shortest, cheapest edge combo. So that's why this is an MST. So what can be the use cases in this real world? Let's say there is a forest with some temperature sensors with batteries, and I want to connect all the sensors with us with the most in the cheapest way, so that if I sense a temperature in one sensor, the other sensors can also sense it. So there will be this is the shortest way of connecting the nodes, and we will find the MST, and when we can all find the shortest and cheapest route. Now, on to the second question. We have to design a data structure which can sum queries and update them in O log n time. So, if we think about a normal array, we can sum them from 0 to 2, 0 to 3, or 0 to 4 manually in O n time, which is not good for us. We have to reduce this time complexity. So, to reduce this time complexity, we will use a data structure called the segment tree. So, what we will do in this thing is called we will treat the inputs here as leaf nodes and pair them into two. So if pairing them into twos, we will first add them as these nodes. So we will add the 0 to 1 nodes, then 3, 4 nodes, then 5, 6 nodes. And adding them, we will get new 3 nodes. And now we will add them also, and we will get two nodes. And after adding those two nodes, we will get a single node. And now we can easily find the sum. So if I want to find the sum of 0 to 3, then we have a 0 to 1, 0 to 0 to 3 is already present here. And if we want to find the 0 to 2 sum, then this is the 0 to 1 sum, and this is 2. And by combining them, we can easily find the sum of 0 to 2. And after that, if we want to update our input, like say we want to make this 10, then easily we can update this by like adding them, and then we get a new node, and adding them we get a new node, then we get a new node, and on to the final node. And this way we can we easily compute the time complexity. See here in this leaf nodes, we have six nodes, then three nodes, and then two nodes, one node. So every time the nodes are halving, and we can see if the nodes are halving, the time complexity has gone down, and we can compute this operation in O log n time. And this is an exact solution of the O log n data structure. But if we want to like approximate solution, we have to use an algorithm or data structure called coarse main sketch, which uses hash maps as the approximator. So if we want just to approximate from a large variety of data, we will use this hash map based algorithm cost minimum sketch. And now to the final question, how to parallelize them. So if we want to parallelize this system, we have to you have to force our in data to multiple local machines, and then pass them concurrently. And this is the way we parallelize. Now, on to the fourth question was about building a system for social graph clustering. So think about some friend groups like A, B, C, and D. So first A and B become friends, then B and C become friends. Now D, C, and D become friends. Now everyone is connected in a friend group. Now there is the magic happens. The parent node of A will be A. The parent node of B will be A. The parent node of C will be B, and the parent node of D will be C. And now, if we ask the question, if D is connected to A, the code will traverse the whole path to the parent node of D will be C, the parent node of C will be B, and the parent node of B will be A. So we can be assured that this is D and A are connected. But now there, this system is now saved in memory, and we can all now always say that D and A are connected. The the parent node traversal is only needed for one time, and after that, every parent node configuration will be an instant. And this is a huge fast algorithm which is called the unified algorithm. And this algorithm is very useful for our social group clustering, as it can easily find the parent nodes because it has already saved the parent node directories, and will give the answer pretty fast. And so how can we use this in a real world ML system? We can use this in a way like the fraud detection. So think about this as the fraud detection distribute some information to B, to C, to D. If and now, if we want to know if D is a fraud information, then we can just traverse because it has already been traversed. We already will be know that this is a fraud detector. Now we have to build an ML model cache by using two systems, Splay tree system and LRU cache algorithm. So first we have to look about the Splay tree system. So this is an initial tree about some input nodes with some information. So think about this node. Think about this node, and if we transform this node to this node, now the node we selected is adapting the tree to around itself. Think about this in this ML cache system. The more new information or the previous information or the recent information we want to access, the node recontextualize its constituents around itself. And this is a really cool feature of this cache model. And the LRO system, what we were talking about, is like a heap system. Like this is a box, this is information. And if we want to put a new information into this system, we have to, there is a limit. So we have to pass out the old information. So which system should we use? That if in a production grid system, we should use the LRU as this is more reliable and the information is in a sequential state. Because if we want to use the split system, it will always reconstitualize itself as the main root node and all the others as the child node. So if we want to just find the 20th node, my latency will go from 10 ms to 100 ms. So we should be more towards the LRU cache system.